Lesson 67, solving and classifying special systems of linear equations. So, the special systems means we'll end up with two solutions, types of solutions. Okay, we've already solved ones where we have answers. Now we're going to solve ones where we get infinitely many solutions or no solutions. Okay, so that's the special type that we're going to see here. Example 1, we're going to always set these up, remember, in the two-column kind of format. We have to solve negative 3x plus y equals a negative 4. And y equals 3x. So I'm going to let you guys choose what you want to do. What is the easiest method that you can see from these two? Sadie says elimination. I don't agree that that's the easiest. It might be the easiest for her. What about anybody else? We have 4 options. Substitution. Why substitution? Because it already has y isolated, so we might as well plug it in, right? Good. So if I was going to do substitution, which I would in this particular case, because it's already set up for me, I don't have to change anything. Let's see. Y equals 3x, so I'm going to plug in that 3x for y. So here we go. Negative 3x plus 3x equals negative 4. So what happens to my negative 3x and my positive 3x? We combine them, and then what do we get? 0. They cancel out, right? So basically what I get is 0 equals negative 4. Is that true? No. If I get something that is not true, that means, whoops, I want to spell it correctly. If I get something that's not true, that means there is no solution. Okay? No solution at all. That's exactly what you would write. You'd write no solution. If it wants you to write it in sentence form, you'd say there's no solution for this system. So no solution. Anytime you end up with something that is not true, it is a no solution problem. Okay? Any questions there? If you would have done elimination, you would have gotten the exact same thing, Sadie. Okay? Example 2, we're still going to separate these into 2 columns there. We have x plus 3y equals 6. And 1/3 x plus y equals 2. Okay, still separating these into 2 columns. I have a new set of problems here, so I'm going to ask again, what do you want to do? Do you want to do elimination? Do you want to do substitution? Do you want to graph it? Elimination, okay? In my opinion, I would want to change this fraction because I don't like dealing with it. What do you guys want to do to eliminate? What do you want to get rid of? You want to get rid of an x or a y? I got told get rid of an x. Okay, that's fine. I have an x in each one. Are they opposites? No, so I'm going to have to multiply by a negative somewhere, right? Which one am I going to multiply? The right or the left? The right side. Now, what do I multiply 1/3 by to get 1? 3. So I'm going to multiply by a negative 3, right? So I can get it opposite but the same. So I multiply this whole thing by negative 3. When I multiply negative 3 by 1/3, I get negative x minus 3y equals negative 6. Most common mistake is you always don't distribute this to every piece of the equation. Make sure you do that. Okay, copy paste, put that right over here. Negative x minus 3y equals a negative 6. Equals plus equals equals equals, and I go straight down. Okay, you will notice something interesting happens here. The y is also canceled out. So I have nothing left. I have 0. What about this 6? They also ended up canceling out. I get 0 equals 0. Well, is that true? Well, 0 of course equals 0, right? So it's true. That would mean that we have infinitely many solutions. Now, because this doesn't sound like it makes any sense, right? If I have infinitely many solutions, that means any numbers that I plug into both of these equations will give me the correct answer, because the equations are the exact same thing. If I multiplied this through by negative 1, I'd get x plus 3y equals 6. X plus 3y equals 6. If the equations are exactly the same, then the graphs of them look exactly the same. Okay? That's what it means, is that all of the answers share. So on the bottom of page 437, there's this chart, and I want you to copy down the examples. There's 3 of them. So you're going to need 3 sets of axes. Now, this is the ones we had been dealing with before. When two lines crossed at exactly one point, we found their intersection, and their intersection was the answer. In this case, there is one answer, and it is represented by x comma y. Whatever the variables stand for, whether it's 1 comma 2, negative 1 comma 2, whatever they stand for, it is one answer, x comma y, and that's how you'll write it, x comma y, in parentheses. You don't write it in parentheses, it's not a coordinate pair, it's just a list of numbers. Okay, the next set is where we have this line, okay, and then there's a second line, but you can't really see it because it's exactly the same as the first line. It's right on top of it. So let me demonstrate that one with a marker. It's right on top of it. You can't see it because it is right on top of it. That means every single answer is intersecting with the same exact line. So this thing intersects the entire time. That's why there are infinitely many solutions on this one, because it is always intersecting. Infinitely many solutions. Don't forget your arrows. This becomes a lot more obvious when you have arrows that go infinitely in both directions, and you have a line that's on top of it itself infinitely in both directions. Okay? Any questions so far on either of these? Okay. Next one is when the slopes are the same. Okay? These guys will have the same exact slope, therefore they'll be parallel. Okay, I'm going to write that note right there. Same slope. Same slope, different intercept. Same slope, different intercept. So on this one where it said infinitely many solutions, that also had the same slope, okay? But instead of a different intercept, it has the same intercept on the one with infinitely many solutions. So the difference in these answers is these two lines never intersect, and these ones always intersect. So since these have a different intercept, y-intercept specifically, then they will never ever cross, therefore there will be no solution. Okay, those are the three types of graphs that you'll see. And those are the three different types of answers you'll have. You either have one answer, no answer, or a million. Infinity actually is the specific number direction. More than we can count is kind of the gist of what we're going for here. Any questions over that? Okay. We're going to try to do it by looking at it this time, or just manipulating it a little bit. Okay. So example 3 does that for us. It's example 3. The numbers are x minus 1/4 y equals 3/4. And of course we're working in two columns again. Then we get 2x plus y equals 1. Okay. Normally when I see these problems I go, I am not going to deal with fractions. I'm going to get rid of that thing right away. So how can I do that? Well, I look for the common denominator. What's the common denominator here? It's 4, right? So I'm going to multiply this whole thing by 4. If I find the common denominator and I multiply it out, then I can get rid of the fractions. Guaranteed no matter what. Okay? So 4x minus 1/4 times 4, which is just 1, gives us y. And then 4 times 3/4 gives us 3. Okay, so now you should notice something. Okay, if I do notice this, then I can finish without even having to do much more. My y's are opposite. Okay, so that actually does help us. If our y's are opposite, then I could use elimination, right? But look what, well, let's just go ahead and classify the system. If our y's are opposite, we don't have to do anything else to do elimination, right? So that's nice. If I solve this, it'll tell me the kind of solution I have. It says determine if each equation is consistent, independent. I'm about to define those terms, which means doesn't have an answer. So does this have an answer is what it's asking us. So those eliminated, and we got 6x. I'm going to go ahead and solve this, but just because I want to show you what it means to be consistent independent. Are we going to have an answer for this problem? Why would we not have an answer? I just had one. X equals 2/3. There is a solution for this problem. It's x equals 2/3, and then I'd plug back in and find my y, right? My y would be some other number, but my point is that I got x equals something. So does it have a solution? Yes. How many solutions? One or infinitely? One solution. So one solution means that it is consistent because it has an answer. Consistent means it has an answer. Okay, so make that note if you don't know. Consistent means it has an answer. Then it asks, is it consistent independent or consistent dependent? If it has one answer, then it is independent. Consistent independent if it has one solution. Okay? If it has infinitely many solutions, it is consistent dependent because they have the same exact slope. They depend on each other. The equations have a lot in common. Okay? So we're going to go back up here to our graphs, and we're going to add in consistent, consistent dependent, or consistent independent. Okay? These guys do not have the same slope. So is it dependent or independent? They don't have the same slope. Do they depend on each other? No. So it's independent. Does it have an answer? So it's consistent. So this one here is consistent because it has an answer. And then it's also independent. Whoops, let me spell that correctly. It will be beneficial. Okay, so this one's consistent independent. Here, it has the same exact slope. So is it independent or dependent? It's very dependent. It has an answer, right? So is it consistent or inconsistent? It's consistent. So it's consistent dependent. And on the last one, there is no answer, so is it consistent? Is it consistent? No, it's inconsistent. I've never seen it classified past inconsistent. But if I was to say that it was something other than inconsistent, I would say it is dependent. But I've never seen it classified anything past inconsistent. Okay? So there is no solution. You just put inconsistent. No solutions. Okay? So when I ask you, is it consistent or inconsistent, you say, does it have an answer or does it not have an answer? Okay? That should be your immediate thought. Okay, let's go to part B of that same example. This one is 3x plus y equals 2. Again, I'm splitting it into two columns. And then y equals negative 3x minus 4. Minus 4. Okay, I can change this really quickly to make our answer obvious. Okay, if I was going to use elimination, Sadie, what would I do first to the right side? Yeah.
It's already opposite.
It's already opposite.
Yeah.
But see how it's not in the same form? This is, I would have to move it. So I'd move it by adding 3x, right?
Yeah.
To both sides. So I'd get y plus 3x equals 4. Now, notice that if I just rewrote this one with y on the other side, it would be the exact same thing, right? Or if I wrote this one properly with x in front, it would be the exact same thing. 3x plus y. So I have the exact same thing up front, right? But the back is different. So what would that tell you about our slope? If they're the exact same, what does that tell you about our slope? It's going to be parallel, right? Now the question is our y-intercept going to be different? If I was going to eliminate these, I would go ahead and multiply it through by -1, and I'd get negative 3x minus y equals negative 4, right? And these would eliminate, and I'd be left with 0 equals negative 2. So what does that tell you about our solution? There is no solution. It is inconsistent, right? So to classify this, because that's what it means when it says classify this as inconsistent. And in most of these, if you can see it before you write it down, you don't even really have to do much work. Put it in proper form, and it's fairly obvious to see. As you do these more, you'll develop that. ability to see where they're going. Okay, example 4 and last example. Example 4 says Brandon started jogging at a rate of 4 miles per hour. After he jogged 1 mile, his friend Anton started jogging at the same path at a pace of 4 miles per hour. Okay, so the first guy was Brandon. I'm going to put B next to his name, and the second guy's name was John, or Anton, sorry. So I'm going to put Anton's name right here. 4 miles per hour. Okay? If they continue to jog at the same rate, will Anton ever catch up to Brandon? And explain. So let's look at our equations. Okay? What is the rate of change here? What is the rate for each person? 4 miles per hour. So if we're traveling at the same speed and the other guy's a mile ahead, is he ever going to catch him? No. If I was going to write equations for this, it would look like this. Y equals my rate plus my initial start, which was 1 mile ahead. And this guy was like y equals 4x. So what do I see about my slopes? They have the same what? I just said it. They have the same slope, but they have different intercepts. So they're parallel, but they will never cross, so there's no solution. They will never catch up to each other. So to answer that question, if we set up the equations, it would be no solution. But to answer the question specifically, it says, will Anton ever catch up to Brandon? No. Now explain why. It says to explain why they have same slope but different intercepts. They will never catch up to each other because their rate of change is the same, however they started at different points.